बिस्मिल्लाह रहमान रहीम। अच्छा, मार्च 2022 का क्वेश्चन नंबर 1 है। A sphere of radius 2.1 millimeter falls with a terminal constant velocity through a liquid as shown in figure 1.1. Okay, so there is a ball, a sphere which is going inside the water or liquid with a constant velocity, which means terminal velocity, which means there is no force, or either the forces are balanced, and has a radius of 2.1 millimeter, whereas the weight is already provided. Liquid also has some density, that is rho. Three forces acts on the moving sphere. The weight of the sphere is 7.2 exponent negative 4 newtons, and the upthrust acting on it is 4.8 negative 4 newtons. The viscous force Fv acting on the sphere is given by this equation, where r is the radius of the sphere, v is the velocity, and k is a constant. The value of k in SI units is 17. Determine the SI base units of k. Okay, so first of all, if you need to find the SI base unit of any value, just forget all the constants, all the values, constant values, and just assign the base units. For example, right now I have the formula Fv is equals to KRV, and I need to find the base unit for k. So I'll make k the subject like this, RV. Now I know that Fv is my force, so force has a base unit of kilogram meters per second square, or you can say kilogram meter second minus 2. R is radius calculated in meters, and V is velocity measured in meters second minus 1. Okay, so now you just need to adjust them. Kilogram meter second minus 2 over meter square second minus 2. So this would be cancelled out, this would be cancelled out, it would remain kilogram per meter. It should be something like that. And there's a mistake over here, that this is minus 1, not minus 2. So if I remove this, it would be minus 1, so remaining would be minus 1 on the top side. So this would be second. So overall it will become kilogram meter minus 1 second minus 1. I hope this question will be cleared for you all. So the next thing is, use the value of the upthrust acting on the sphere to calculate the density rho of the liquid. Okay, so right now I do know that there is some, I do not know the value of density over here, but I have some formulas from which I can deduce the value of density. Number one is density is equals to mass over volume, but I do not know the volume. And the next formula is for the liquid for pressure. So the pressure over here would be equals to rho gravity height, and if I change the value of pressure, it would be force over area is equals to rho gravity height, and if I multiply area by height, it would become rho gravity volume. So right now if I need to find the value of F, what I can do, I can simply actually I already know the value of F, I just need to find the value of V, volume, so in order to get the value of density. So as I know that this is a sphere, so a sphere has a volume of 4 over 3 pi r cube. So if I plug all the values over here, that is 4 over 3 times pi times value of r over here is 2.1, that would become 2.1 negative 3 cube. So my volume would be 3.3 3.88, you can just write it 3.9 negative 5, sorry, negative 8 meters cube. Now the problem is I have two values over here. Number one is the upthrust that is acting on it, and the other one is the weight that is acting on it. So which value should I need to take it over here? So in order to calculate all these values, you need to know that the pressure that is acting over here is due to the upthrust that is going on the top side. So for that, you need to first, because it is also saying the value of thrust acting, so we'll simply take the value of thrust over here. So for now, the formula would be shaped like this: G times V, that is equals to rho. Value of rho would be 4.8 negative 4 over 9.81 times this value, that is 3.9 exponent negative 8. So I get the value of rho as 1261 kilograms per meter cube, and if I round off to two significant figure, or 3, for 3 it would be 1260, and if I go for 2SF it would become 1300 kilogram per meter cube. So I'll stick with 1300 kilogram per meter cube because all the values on the top side are in two significant figures, that's why. Okay, so the next part is, on the sphere in figure 1.1, draw 3 arrows to show the directions of the weight W, upthrust U, and the viscous force Fv. Label these arrows V, U, and WU and Fv respectively. Okay, so all of us knows that weight will always acts downward, so the downward arrow would be for weight. The upthrust, I already know that it's going for top side, that becomes U, and the Fv is the viscous force. Actually the ball is going downward, which means all the viscous force that is acting on this ball will go towards upside, so that would be Fv. Okay, so the next part is determine the magnitude of the terminal velocity of the sphere. So for now I need to find the Fv first, then only I can find all the values. So that would be upthrust minus weight, whatever the value comes. In my case the value is coming 2.4 exponent negative 4. How this is comes? It comes by subtracting 7.2 exponent negative 4 minus 4.8 exponent negative 4. So that's how my Fv comes here. Now I know the value of Fv, I know the value of R, I know the value of K. I just need to make V the subject over here. It would become like this. I just need to plug the values now. The values have been plugged already. I remember the value of K as 17 and the radius was 2.1 exponent negative 3. So in the end my value is something like 6.67, so I can round it off to 6.7 exponent negative 3 meters per second, and this is my answer. The question is solved over here. Thank you very much.